Well, good morning or good afternoon, depending on where you are, everyone. We're just going to wait about 30 seconds to let some stragglers come in, and then we'll get started. So there'll be, 30 seconds of awkward silence while we wait for the rest of our colleagues to join us. All right, well, that feels like we've waited long enough. So I want to welcome everyone to our webinar this morning. Today, we're going to actually be talking about how to inject CodeSonar and static code analysis in general into your DevSecOps pipeline to help your team go faster, to find problems sooner in the development cycle, to deliver more safe and secure code, basically to reap all the benefits of DevSecOps with a little bit of a turbocharge kicked in from static code analysis. We are going to record this session. So if that makes you uncomfortable, please feel free to drop at this point. People who are signed up will get a link to the slides and a link to the recording, I believe. So you won't miss anything, but if you're uncomfortable being recorded, this is your opportunity to drop out now and to watch this at your own leisure. I am a product manager at Ada Core. It's going to take me a while to get used to saying that. So I am responsible for CodeSonar, our static code analysis tool for C, C++, Rust, Ada, and a number of other languages. This is my, I've been a product manager for about a decade, so lots of industry experience. And I will be walking you through what we consider to be the best practices around using CodeSonar and DevSecOps. If you are a little unfamiliar with the concept of DevSecOps, I'll introduce it briefly in the presentation. But at the moment, even before we get started, I'm curious to know from the people who are participating what your journey along the DevSecOps process is. So my colleague will be popping up a survey at this point to ask you where you are on that journey. What we're really interested to know is the audience in this presentation just starting? Is it something that you are considering? Is it something that you are planning to do, or that you're well along the way and you're really here to see how static code analysis can help you do it better? So hopefully you'll see a survey pop up on your screen. Let's just see if that's the case. Yep, there it is. Fantastic. My colleague Karis is in the background silently making all the magic happen. All right, hopefully that's enough time for everyone. And we'll just move on. Let's dive straight into our content. In this presentation, I want to cover off some of the business drivers for DevSecOps. This will serve as a little bit of a primer for people who are new to the concept or who have heard this term of art, but are not necessarily sure what it means, or just separate some of the really important details from the marketing buzz. Talk a little bit about how our current development processes offer certain challenges around adopting DevSecOps and how we might want to think about things differently. Touch briefly on how static analysis helps development in general, and then really talk a little bit more about specifically how to adopt static code analysis in your DevSecOps discipline, I guess is the best way to say it, and how static analysis and specifically CodeSonar can really turbocharge that. So with automation and other techniques that we'll talk about, you can really get to a state of empowered development. So DevSecOps is a broad term of art in our industry. At its core, though, there's some really clever ideas, I think, specifically how every team that's responsible for delivering your software, whether it's development, who create it, testers who touch it and make sure it's working correctly, the operations team that delivers it to your customers, everyone has some skin in the game. So what we're really working to do as an enterprise or as a group of people is to scrub all of the friction out of the system that you can, so that you can always be ready to deliver. So any quanta of change that your development team creates should be running through your DevSecOps pipeline, and it should be tested and examined and considered all the way along the process, so that if you wanted to, you could ship tomorrow. Now, our partners in industry, they can ship multiple times a day. That's not really what our objective in the embedded space is. We have a much different kind of release cycle, but quite frankly, that is a very compelling outcome, that confidence that every change is safe. So as you think about adopting DevSecOps for your team, there are certain characteristics that are true no matter what industry you're working for or in. The most important thing is the no blame ethos. So the idea behind DevSecOps is you've built a pipeline. It's as automated as you possibly can make it. Legacy systems are respected and potentially havered off and dealt with separately, but we automate and orchestrate as much as we possibly can. And then as change moves through that pipeline, when I say respect the culture, what I really mean is if there's a problem, we manage it. We don't worry about every individual step along the way. If something fails, we fail forward. We don't blame anyone. We go and we fix that failure, and we circle back and we do it again. So we're always trying to refine the pipeline to make things better, to make sure that everybody's voice is heard, and that the pipeline that we've built, the automation that we've created, is as efficient as possible. And that means when something actually fails, it's easier for us to detect that. And that's what I mean by data everywhere. We want our tools to generate data so that we can create dashboards, data lakes, and information so that we can audit and understand where failures take place. The other thing that we've seen is that people take small steps. And I think you'll see this reflected later on in this presentation, where we talk about crawl, walk, and run. So when you're adopting static code analysis, really the best way to do it in a DevSecOps adoption or process or discipline is to take small steps. Do something, measure its outcome, make sure you've got it dialed in correctly, take the next step. And so later in the presentation, when we talk about how, that's the approach that we're going to take. Now, collectively, if we adopt some of these concepts and we do this in a stepwise fashion, there are some measurable, tangible benefits that you can put down on paper and start to track your progress against. So obviously, everybody knows that detecting and remediating vulnerabilities early in the development cycle leads to better security. We'll talk a little bit about why that is, but it really comes down to human nature. The longer you put something off, the harder it is to get it done, and the easier it is to think, well, maybe I can skip it this time. There are tremendous cost savings that come along with an adoption of DevSecOps. So while it can be costly and difficult and challenging at the onset to consider doing this, the cost savings for teams are actually measurable. So again, everybody knows more or less within a couple $1,000 how much every bug costs to fix once you've shipped, or if you find it in test. So this idea of shifting left saves both costs at the development, but costs in deployment as well. Everybody's had the "it works on my machine" experience as well. So improving collaboration comes with other benefits: less frustration, better performance, a lot better insight into why something is important and why it's not. So a security team might go to a development group, and if you have DevSecOps in your system, right? If you have that ability to say, I don't come to you every day with a raft of problems that you have to wave your hands to get rid of. I'm only coming to you with the things that we've identified as important. It does improve collaboration, and it does improve rapid and effective resolution of these issues. And we all want to go faster, right? Regardless of what industry we're in. Even if we're not shipping 30 to 60 changes to our web-based app a day, which is what happens at places like Google and other service providers, or banks for that matter, what we're really looking to do is just hit our targets. Be fast enough and efficient enough and have enough confidence in what we've built that when it comes time to ship on time, we're not missing our market window, that we're actually hitting our targets and doing what we committed to. I know every developer really takes pride in this. And when you can't hit those dates, it's profoundly frustrating. So DevSecOps kind of has lots of benefits baked into it. And by adopting some of these best practices, we can really all achieve more of our objectives. So let's talk about the current state of the art. And some of this will apply to everybody who's sitting here on this webinar. And some of this you may have resolved it, or this may be past trauma that resonates. But in the current state of the world, if we think about the traditional approaches to software development, oftentimes the development would take place and then some kind of dynamic testing or some kind of code review would take place after the fact. That's not a terrible way of approaching things. You have to do it. The problem is it generates a lot of data at a time when perhaps you're not ready to deal with it, or that haystack effect, that all of that information doesn't really generate the kind of insights that you need to make good business decisions. So there are certain kinds of data in that haystack that are relatively easy to sort out. They're just low-level frustrations. So if you're trying to follow a coding standard like MISRA or AutoSAR or CERT that have certain kinds of restrictions on the way that you express your solution, well, those aren't really difficult and they don't require a lot of debate. But if you have a hay in your haystack that's a security violation, well, now suddenly you're into a gray zone. Is this really a vulnerability? Can it be exploited? Is this something that we need to fix now? Is it even worth triggering a retest? And so you can talk yourself out of dealing with that insight and doing the right thing. And that breaks DevSecOps. If you think about that ethos of no blame, fix the problem, work the problem, fail forward and solve it for the future, finding those problems late, having that haystack of data discourages that, right? So the temptation is to say, oh, it's so late in our development cycle. Is this really that important? And that's where things creep into your solution that you just don't want to ship with. You had to make that decision. It was probably the decision that made sense at the time, but it can lead to long-term costs and security vulnerabilities and other negative impacts. So the traditional method, we've all experienced those late-breaking defects that impact your release timelines. This is just, we've accepted this as the cost of doing business and the cost of development. But wouldn't it be great if we could find those defects sooner, right? That's the promise of DevSecOps. Security vulnerabilities, I don't know about you, but keeps me up at night wondering what's shipped that we didn't find. I'm sure you feel the same way. Again, it's something that we've accepted as just the challenge of writing so much of the value of our solutions in software now. It's very mutable. It can be changed quickly. Things evolve. Teenagers, pimply-faced teenagers in their mom's basement are already figuring out ways to crack the security that we've come up with so far. So again, having a process and a discipline that allows you to detect these early is a good thing. And nobody wants to frustrate their developers. I was a developer at the first part of my career, and I can remember how frustrating it was to get bug reports from people who didn't get it, and didn't understand my brilliance. And again, it is real. So these are all negative impacts of the traditional way of doing things when we're trying to adopt DevSecOps. So there are lots of ways of addressing those, but I'm a static analysis tools PM, so I'm going to talk about how static analysis, just in general, can help with that. So a tool like CodeSonar or other static analysis tools can detect coding standard violations. Those are those easy bugs to fix. So just don't commit code that has them, right? So a tool that can find that for you quickly is great. But static code analysis is a bit like magic, and it can find other stuff too, like behavior that's undefined or zero-day vulnerabilities because you have forgotten to check the size of a buffer before you write to the end of it. It can detect things like taint if there's tainted data that's flowing through the system. It can detect things like API violations, just inadvertent stuff that these are mistakes that people make every day. Now, having that kind of information at your fingertips certainly reduces the long-term support cost of your code. You're not going to introduce bugs and then have to fix it when it's more expensive. Or if your colleague takes over the module that you're responsible for or the library that you've written, then that person will actually be able to say, hey, this is a really well-written piece of code. It's documented, it's properly constructed, the API is well defined, there's nothing bad in here that I need to sort through. Things like buffer overruns or underruns or divide by zero errors, they just don't exist in here. So my maintenance cost goes down. And that's generally speaking, no matter whether you do DevSecOps or not, or those are benefits that you get. That's just in part of static code analysis. But remember, today we're not talking about that. We're talking about how to turbocharge my DevSecOps discipline. So a traditional SaaS implementation still doesn't solve your Haystack problem because typically people integrate it as part of their daily build cycle. So people have already committed a raft of code onto their main branch, and they're just running static code analysis as part of their build, which is great because it's going to find those problems that I talked about. It will catch those coding standard violations, and it will find security vulnerabilities and do all the good stuff that we just talked about. But it's going to send out a whole bunch of warnings to developers as part of that process. So you're going to wake up tomorrow morning with an inbox full of things to address. So that still is not generating insight for you when you really need it. Still leading to that frustration, still leading to that possibility of delaying fixing something or convincing yourself that it's not important. So you're not quite there yet. But the good news is it's actually not that difficult to take the benefits of static code analysis and marry it to the benefits of DevSecOps. And that's what the last part of our presentation is going to be about. So let's make sure that we are adding static code analysis. And hey, I'm the CodeSonar PM, so I'm going to try to convince you to use CodeSonar to your DevSecOps practice. So we've already talked about how finding problems early is good. So it shifts the cost and the burden of addressing them to the left on your time x-axis. Helps you write better code. Talked a little bit about that in the previous slide as well. This is great because we want to fail forward and deal with problems as they come up. There's actually a fundamental challenge I think we all face today, is that there are fewer and fewer graduates who are graduating with really deep insight into C, C++, and some of these languages that are popular in the embedded space. So there's kind of an interesting echo effect or halo effect that happens with static code analysis tools, because it will say, here is a problem and here is why it's a problem. And you can Google that and see how to write something better. Or here's a suggestion that you can find from other tools on how you can actually create better code and become a better developer. So yes, it will help you write better code in the short term, but it will also help train some of your new developers to write better code in the long term. But again, that all of this good stuff, like useful information about the detected problems, you got to get it into your DevSecOps pipeline. So how does CodeSonar specifically address some of the things that we talked about with DevSecOps? Well, first of all, static code analysis is really a white box testing. So you always have code available when you're diagnosing the warning. So you will always have information at your fingertips to solve problems by exception. Remember, we want to fail forward and deal with the exception. So having a white box where I've got the code helps me do that. I'm not worrying about everything. I'm just fixing my one problem. Because you don't need to run a dynamic test. You don't need a functioning build to do static code analysis. You just need to have a build. It's perfect for automation. I can automate static code analysis anywhere along the line in my process and get those results. Exactly what you want with DevSecOps, where you're trying to automate as much as humanly possible. I can validate the coding standards and tune what I'm looking for so that my team is only generating the information and the results that give me the insights I care about. So maybe I'm not using a coding standard. Great. I'm not even going to check those rules. Maybe I'm concerned about security or reliability defects or code smells, right? I can dial in CodeSonar to just check those things. Maybe I'm worried about metrics and achieving a certain level of documentation or lines of comments per code or complexity or coupling, right? All of that information helps me to be a better developer, but I can dial it in and I can make stepwise changes to that dialing in so I get exactly the results that my team needs for the way that we want to code. Now that might sound small, but if you think back to one of the successful adoption practices is start small, make a change, measure, adapt, and make another small change. So having a tool that allows you to dial in exactly the stuff that you want really helps support that methodology. So there are 4 things that I said are the likely outcome of adopting DevSecOps. So let's talk about enhanced security. This is a big one, right? This is the stuff that we worry about because of the cost of making mistakes. So having a tool like CodeSonar specifically, but I would argue that tools that are more superficial probably aren't going to get you the same bang for the buck, but let's concede that anything is better than nothing. At least with CodeSonar, what we do is we watch the build. We observe the entire build. We know exactly what command line arguments you've passed to your compiler, and we create a model of your code as it's being built. So we don't, if def debug a whole bunch of stuff out, we're not going to look at it. We don't care. And we take that model and we apply a bunch of solvers and formal methods to make sure that we're only reporting results that will take place while the code is running. So we can watch the entire call, or we analyze the entire call stack for every warning that we're going to find. We kind of separate out the stuff that doesn't matter. So if this warning only manifests when you follow a certain path, that's the information that we're going to show to you. So the results are actually very, very accurate relative to the size of your code base. And we're not going to waste your time showing you stuff that you're not going to hit. And then finally, and perhaps the most important element of CodeSonar specifically, is we store those results. So there's a historical database of every analysis that you ever run, and you can keep it in perpetuity in the database for review, for an analysis of how serious something is, and then final disposition of a warning. So if you decide that you don't care about it, you can always flag it as something that well, this is just technical debt, and we're willing to live with it. And remember, for a good DevSecOps practice, data everywhere. You want that dashboard, you want that information, you want to be able to audit the results that you're getting. On that front, as I mentioned, we maintain a record of every run that you basically tell us about. So you run a build, you ask CodeSonar to watch it and to analyze that build. Every analysis that you run will be stored in the hub. It's what we call our database and web front end. Every warning that we find is ranked. And remember, in DevSecOps, I want to manage by exception. So I want to see the things that are important today. So our scoring system allows you to get a really quick stack ranked view of the severity of the different kinds of warnings that we find. So in this particular run, we found a bunch of leaks. In this particular scoring heuristic, those are deemed to be more important than, say, an uninitialized variable, which is less dangerous. We also score this based on the likelihood of this happening. Remember, we have that deep insight into the call stack. If you have a standard like MISRA or CWE or a taxonomy, we'll make that information available on a per warning basis. So you'll be able to say, hey, just I want to see every bad warning that maps to these particular taxonomies. And then finally, every warning has a state: priority, finding, is it open, is it closed, is it important, is it don't care. And this is all searchable, so that when you're trying to diagnose whether the flashing red light is something that you need to pay attention to on this particular analysis or something that you can ignore, this is a really quick way of drilling down into the specific information that you're trying to address, or the specific finding that may have flagged something on your dashboard to say, This particular DevSecOps run, this quanta of change that we're testing, this has raised a flag for us. So the ability to have all of that information at your fingertips is very valuable. So this is part of the way that it's going to help support your DevSecOps practice. The thing that's often overlooked, though, is why deep analysis matters. Why is it worth spending that time to generate the model of the program, a deep understanding of the call stack, to scrub out information that's not relevant? Largely, it comes down to human nature. If I generate a ton of shallow, superficial warnings, and I just present that to the developers as, here's a big pile of stuff to worry about, a lot of times what we're training people to do is ignore them, right? Everything's a problem, so nothing's a problem. Yeah. You flagged that to me a dozen times. I looked at it last week. I didn't care about it then. I don't care about it now. It's not what we want to train people to do. We want to train people to say, there is a warning. This is part of our process, is to go and look at it and make sure that it's not a problem. So a deep analysis will show you both the actual warning, which you can kind of see towards the bottom right of my screen, right? Here's an explanation of what we're telling you. This is something that's referenced, but it's, the resource seems to have disappeared. But we also show you the path to get there. Although it's a little, hopefully it's popping up on people's screens, but what you're seeing here is the path through two different compilation units to get to that warning. So we start in one compilation unit that has init in the name. It allocates something. It makes a function call into something else. And that new piece of code in a different compilation unit is actually displayed here. So now I've done something that humans can do, but can be quite tricky in real time, right? I've gone into the special compilation unit, identified the exact line of code that this problem manifests in, but the tool did it for me. I don't have to do this myself. So my cognitive load and the challenge around trying to diagnose why the tool is reporting this warning is much lower. Now, I can assess at this point, okay, I see the path through the code. I see all the if statements that I have to evaluate to true or false to get here. Is this likely to be a problem? Well, now you've given me a lot more information. And I'm not just saying, I don't care, it's superficial. You're always telling me about this. You're saying, oh, wow, here is a piece of information that I can do something with, and I can make a decision. I can go to a colleague and say, hey, do you mind standing over my shoulder? Let me just walk you through this verbally, what's going on. And if you agree that it's not a problem, you can take that warning, give it a new attribute, say, don't care. You could give that a really, this is really, really bad. So now we have to do something with it. But that information, that deep analysis really matters. And it's actually part of the thing, although it feels like maybe it's overkill, it really drives good behavior in a DevSecOps practice. All right, talk about speed and efficiency, because I've just said that we give you more information and that might slow you down. It really doesn't. So with static code analysis in a DevSecOps practice, what you're going to do is you're going to start testing new work before you merge it into the main branch. Remember, I said that static analysis is good. It's like taking vitamins. It's better than taking medicine. But in a traditional sense, when people just merge and then they do the static code analysis, they still get that haystack problem of lots of results way too late to do anything about it. But if you start to use DevSecOps in static code analysis the way we recommend, work gets tested before you even merge to the main branch. So you can do peer review, as I kind of waved my hands about in the previous slide. You can do your static application testing on your desktop or in your local sandbox. You can do all of this stuff either on hardware or in simulation, depending on what kind of testing you do on the desktop. You can even bake in policies around security and quality. So you can have a quality gate that is tied to your static code analysis, and it will say, you can't commit this code. You can't do a merge request or a pull request until you meet these requirements. So that actually improves the overall speed of your DevSecOps pipeline because you're not putting garbage into it. So there are lots of ways of improving security or improving the speed of your team by fixing things when they happen, instead of waiting till the pipeline fails. And if you really wanted to be strict about it, you could even say, hey, we have to have a review process. We have a tool that drives that particular engine. CodeSonar can talk to a variety of different tools and feed those process engines with information. So if you do have a merge request that isn't going to pass your quality gates, you can still have it approved and go through that process, and then document the fact that you've agreed to this deviation and sort of store a record of that. So again, the idea here is to improve efficiency by running CodeSonar a little sooner in the development process, and we'll talk about how to get to that in a couple of slides. I mentioned that we collaborate, or we fit into lots of different tools. We've designed CodeSonar to essentially fit into your pipeline no matter how you want to construct it. I don't want to be too prescriptive, but quite frankly, there is better ways to do things and less better ways to do things. But no matter how you choose to integrate static code analysis, we've tried to build CodeSonar so that it will fit. A lot of people now are sort of the focus of their development and the focus of their analysis is really in a GitLab or GitHub merge or pull request. So we have deep integration into those tools. So if your way of work is to focus, the developer tends to focus at that interface on that pane of glass. We have integrations into both the security reports in both of those tools. And that big list of warnings that I showed you can be shrunk down to just your quanta of change. If you're using Jenkins to orchestrate that automation that we talked about, great. We have a nice integration into Jenkins. We have other automation tools that we work with. Jira is a great way to take a warning, where it's a good example of taking a warning, giving it some kind of attribution. This is important, this is critical. I'm going to assign it to somebody. That integration is possible from a warning. Or if you want to do quality metric or some sort of quality gate or some kind of process engine like Garrett or Bitbucket, we have integrations into those as well. We also, as I said, one of the things that we're trying to encourage is running your static analysis and while you're writing your code. So can't do that unless we have integrations into things like IDEs. Of course we do. And then, for different kinds of build systems, we integrate with, your typical build systems, but we're also adding the ability to do distributed build and analysis through Bazel or CloudBees or other tools of that nature. And then ultimately, the really critical integration, if you want to have a dashboard, is output. And we have lots of different ways of outputting the information as well. So I want you to be confident that if you are thinking about CodeSonar for C++ or Rust or Ada, it will integrate into your pipeline. And if it doesn't, we'll create the integration. We understand how important this is to fit. And then, nobody can do a webinar without trying to put a scary slide up. So I apologize for that. But, when we talk about cost savings and we talk about being more efficient, the risk is always when you're making a pitch to do something differently is, well, this is going to slow us down, or we're going to have to buy more tools, or we're going to have to invest in something. So the corollary, though, is if we don't do anything, there are some impacts on not adopting DevSecOps if our competitors are. So there are new and increased market demands on teams to meet different kinds of cybersecurity requirements depending on what jurisdiction you're in today. The Europeans are very strict about this. The US is as well. There are financial penalties. There are certainly penalties to missing your ship date as well, right? So profitability now is at risk if our industry doesn't adopt some of these DevSecOps practices and principles. We all know the cost of product recalls or shipping a product with problems in it. As I mentioned early in this presentation, there's lots and lots of research that talks about how much it costs to support a product and how much it costs to fix a problem. But nowadays, because cybersecurity is evolving so rapidly, there are new standards that are arising, and they pop up. You have to meet them, and you can't support your product in the field because you don't have confidence that the product was written in a certain way to meet that standard. That's nightmarish, really, for companies. So having a process where if somebody comes to you in 5 years and says, hey, there's a new UN standard for cybersecurity and self-driving cars, you can say, yeah, we're good, right? We have a process that guarantees that those kinds of problems aren't going to crop up. We know the cost of certification, failure to certify is even worse. But the overarching thing is you don't want your company's name in the paper. If you can avoid these things, you can offset or defray the concern around how much is it going to cost for us to adopt DevSecOps or add another tool into our pipeline. So that's all great. The real tough question that I want to try to address in this presentation, though, is so how do you get there? We've enumerated some of the benefits of static code analysis. We've enumerated some of the challenges of traditional methodology. We've talked about the benefits of DevSecOps and how we can potentially improve that or even turbocharge that with static code analysis. So what are we going to do to achieve that? I want to be clear that this is this is an opinion. This is one way of doing things. There are no wrong answers here, but we've got some success with other customers who have done this. So we're pretty confident that this is a good way of doing stuff. So the first thing that we need to acknowledge is we're going to need more compute. We're going to do more testing. We're going to do more analysis. But this can be solved by containerization and infrastructure as code. Doesn't mean you have to buy a new server, but it does mean that you need to think about how are we going to deploy the assets and the necessary things in order to do this. We want to make sure that we understand that static code analysis goes into that pipeline that we've built. It's not a nice to have, it's a must have. And then we need to think about how we're going to get data from CodeSonar and get it into our data lake or our dashboards or whatever other tools that we're using on top of that. Now, that might sound daunting, and it can be. So that's why we are going to take the approach of make a small change, measure the impact, go to the next small change. But you need to know what those changes are. So we call it crawl, walk, and run. Not very not new, but basically it is the philosophy. Don't try to do everything all at once. Even if you have a vision in mind, if you try to grab the brass ring, it's more likely to fail. So we've already talked about the haymound and the lots of data, no insight problem. But the best way to start, believe it or not, if you don't do static analysis today, but you do DevSecOps or have the ambition to do that, just start small. Do this as part of your daily build. That will force you to automate it. It will force you to figure out what the interfaces are between your static analysis tool and other parts of your pipeline, right? So you've taken that first step, you've integrated CodeSonar into your pipeline, you've automated it, it all works. The next step is to then shift that automation into every merge and pull request. So every time something happens, I'm going to every time I make a merge or a pull request, that automation that we built for the daily testing is going to kick off, and it will be orchestrated by whatever tool I use for change management, whether it's Git or some kind of webhook that fires when I do a merge request or a pull request. That information will then flow into the user interface that the developer tends to live in, as opposed to that daily test. It will be part of the merge or pull request security report, and they can make some decisions based on that. That's a good next step. It gets closer to where we want to be, but there's still a little bit of a disconnect because you have to make all your changes and then do your pull merge request and static code analysis. But we're starting to drill it, or we're starting to hone in on where we want to get to, which is the run stage. And that is, developers being able to execute a static code analysis whenever they want, having that result available where they are right now, and feeding into other tools like large language models for remediation and explanation, validation, fully automated and baked into the way that your team works. So those are the stages that we recommend. And the specifics of how we recommend doing that is to have, and most people already have this, so this fits nicely, is an architecture that's essentially driven by a bunch of different containerized build elements, like your compiler, your runtime system libraries, any dependencies, your RTOS itself, These are all available as building blocks. You've got some kind of scalable compute, whether that's air-gapped or some sort of on-prem server or your cloud infrastructure like Kubernetes based, so that all of these things are essentially containerized and they run the same way every time. So you're not trying to figure out, did we get this result because we built it the wrong way? And once we have those containerized elements in place, it will be easier to take that run step, which is the next step we want to take. So in addition to the source code, we also want to have our pipeline defined in our change management system. And potentially, and ideally, we'll have some kind of quality policy that can drive acceptance of changes as well. Same thing with any kind of infrastructure as code. That should also be Dockerized or containerized, or at least defined as some kind of chunk. And all of that feeds into your build environment that shares information with CodeSonar. So if we have an architecture like this that is containerized if possible, if not, at least well-defined, something that's repeatable, something that is policy-driven, something that is not left to the developer as an exercise, then it is much easier to put CodeSonar into your DevSecOps pipeline and watch the build and gather that data. So this is the recommended architecture. Something like this, even though this is very much hand-wavy, I think it gives you a flavor of what we're trying to achieve here. So everything is driven out of our change management system and our containerized architecture. Then we start to optimize. So that architecture, this architecture that I've described fits the crawl. It's just enough to get automation working. Now on our walk step, we want to start drilling into a more optimized configuration. So we want to increase parallelism when we can. I described that we have the ability to do distributed build or to watch a distributed build. In our next release, we're going to be able to distribute the actual analysis step that will increase parallelism. We also want to try to reduce the amount of code that we're analyzing on every run. Sure, on our nightlies, we want to analyze the entire code base, but ideally, if I'm just doing a merge request or a pull request, I just want the analysis to run on my stuff. And CodeSonar is more than capable of doing that. You just need to dial it in to do so. So, now I'm tuning things up for that walk step. I also mentioned that, CodeSonar is capable of tuning the analysis. So I'm only really looking at the stuff I care about. And then finally, I just want to analyze my branch. So I need to configure CodeSonar so it's just doing that. So all of these things are kind of a tuning step. And then finally, once I've got that dialed in, I can then put those containers. I can take that dialed in configuration, and every time, and no matter where I'm working, whether it's in my IDE or I'm, have some kind of automation or some large language model that assists me with remediation or coding, all of that just happens automatically where I'm working. So if the developer is working away in, say, I don't know, VS Code, just for argument's sake, they make a change, they start a container, they run a complete, or they run an analysis on their branch, on their machine in a container that is exactly the same as the build system. They can get that policy violation out of Git or GitLab, GitHub, whatever, or one of those policy engines like Bitbucket or Garrett. Those policy violations get reported in their IDE. They make a change, and when they're confident, they can push that back up to their change management system, do a pull request, merge request, and kick off the build. Crawl, walk, and run. Get it working, dial it in, and then make it possible for people to kick off those containerized elements from their workstation. If you can do that, it will improve your development process for all the reasons that we talked about. We know DevSecOps works because people in the industry are using it successfully. It's not vaporware, it's not shelfware. But you can't buy one from your local software vendor. You have to construct that pipeline yourself. We know that we have to go faster. We need to manage our costs. We need to collaborate more effectively. We need efficiency into our development teams. Those are the things that are driving us towards this outcome. And then if you buy into all of that, I hope I've convinced you that both adding static code analysis, and again, specifically CodeSonar, will help you turbocharge that practice. But we also know how to help you do it. So if you need some help, we've got all of this information and can help people get CodeSonar through that crawl, walk, and run process to a point where you're really achieving all of those other objectives. So we have an actual practical demonstration that my colleague Mark has recorded. The link is here in the YouTube. If this is something that you are interested in, just drop us an email. We're happy to reach out. I'm not going to try to sell you anything, even though it does say account manager there. And we're happy to talk as well. And we can always do a demonstration with our technical team who can sort of walk you through some of the hand wavy stuff that I've done just to see if it does fit into your overall process. So now we're going to switch over to the Q&A, which should be interesting. So I guess the process here is I read it and let you know. I'm going to start with Dimitar. Hi, Dimitar. It's been a while. So the question from Dimitar is, in a container world, what is your recommended approach for storing SAST metadata and incremental analysis? It's a very good question. I still believe that having that data in the hub, even in the incremental form, is the right way to go. Now, I recognize that with lots of builds taking place, then becomes a question of storage. And I think that has to be a policy-driven conversation that you have with your enterprise, which is how long do we need to have all of this information available? And you can store the results of an analysis without keeping all of the metadata that's necessary to do that deep dive that I had a slide on. So you can trim down the size of your database for really old things. Or you can have a policy that says, we keep all of this information for a year and then we archive it somewhere in a different store, right? But the hub, I'm convinced, remains the right way to store that information, either for the short, medium, or long term. It's a good question. All right, I've got a question from Jeff Chilton. Looks like your corporate firewall protected me from your presentation. Yeah, so that's actually great, Jeff. Sorry about that. Both the presentation, you can click the link on the bottom to get the slide now, but if you're not available, if you can't get to our corporate firewall, we will be sending out information. We'll send out a link to the presentation and a link to the slides in an email to all the participants after this. Great question. All right, from Raj Shekhar. Sorry, Raj. How can CodeSonar ensure reproducible and deterministic analysis across air-gap, on-prem, cloud builds when compilers, RTOS, Dockers, and different formal verification methods against all configurations? All right, so let's talk about determinism and static code analysis, because I think that's at the heart of Raj's question. So, determinism can be very difficult to achieve, no matter whether you're talking about static analysis or builds. So what I would probably decompose that question into a couple of different ways. And the first one is, we're not necessarily saying that, I think first of all, you want to get to a deterministic system, a deterministic architecture. That's one of the reasons that we are strong proponents of containerization. That way I have a consistent tool lineup, no matter who is executing that empowered developer workflow that we talked about. So once I've dialed in, there's less and less variability from one system to the other. Having said that, I think at the heart of Raj's question is a really important observation, which is the second you start to introduce any kind of variability in my build, I'm probably going to have a non-deterministic build. It's very, very costly and very difficult to avoid that. Because of the way that we operate, because we watch your build intently, even the slightest variation between compilations can sometimes result in different warnings, different result sets. And that can be very problematic for teams who have a process that says there can't be any kind of regression, there has to be absolute determinism. The reason I'm saying it's subtle is if your build system isn't really deterministic, even if you think it is, we will potentially get different results. So we have created some capability inside CodeSonar to ignore or to be a little mushy in the face of a little bit of non-determinism, at the sacrifice of some accuracy. So it's a great question. It is always an interesting conversation to have with customers. I would specifically say we probably want to stick to a one-on-one discussion instead of making broad claims that, we're better than a deterministic build system. But builds are often not deterministic in odd ways, and it kind of manifests in the results. So we do let you kind of get a little mushy. You can also flag certain warnings as false positives or true positives, or just don't care. So there are ways to mitigate it, but at its heart, if you don't have a deterministic build system, our warnings will change with the build itself. Excellent question, and I wish I could give that more time, but we are running a wee bit short. Okay, Katya, does CodeSonar replace Gnat SAS? Haha. Okay, so no, actually it doesn't. So CodeSonar was built initially for C and C++, and we added support for languages like Rust and Kotlin, Java, C#, Go. But we are rather agnostic when it comes to what the analysis engine under the hood is. So CodeSonar today is really a C and C++ analysis engine. But when we have a full integration with Ada, which is coming very soon, actually, we're going to use Gnat SAS to do the analysis and Gnat Checker to do the analysis. And we will talk to libadalang to get the information that we generate ourselves through our current engine. So think of it as supplemental to the way Gnat SAS works. So you'll get all of the Gnat, the Gnat SAS goodness, but those results will now be visible in the hub with scoring, with deep analysis, with path information, with annotations, and the ability to say, I don't care about this, I do care about this, I've assigned this to somebody in Jira. All of those integration I wave my hands about with C and C++ will be available for Ada, but the analysis will take place in Gnat SAS. Another question from Raj. So he asks, how can CodeSonar evolve to use self-learning and formal methods that refine abstract models from runtime traces, development intent, achieving zero false positives, etc.? That is such a good question. So one of the things I'm really excited about is what large language models that are well-tuned and well-suited to our space, the embedded space, will be able to do with that kind of deep analysis that we currently generate. That's true for Ada, that's true for C and C++. So Gnat SAS does the exact kind of deep, insightful static analysis that we do for C and C++. So one of the ways to avoid LLM hallucinations and other challenges of using a large language model is to give it better inputs. And I'm convinced that the deep analysis that we use, that we create, both from Gnat SAS and from CodeSonar, will actually feed into those large language models a much more accurate representation of a warning. And we can say, is this a false positive given all of that context and this project? When it comes back with some kind of answer, I think that's where we can start to build some refinement into both. I mentioned how configurable CodeSonar was. So the workflow that I envision is a problem occurs and you can automate this. You can feed that into your large language model to say, can you validate this result set? If there are false positives or false negatives that are detected, that gets flagged to the team through some sort of dashboard mechanism. You can go in, take a look at that specific warning, and then you can either reach out to us to get an improved algorithm, or you can dial in the configuration so that it ignores or flags that that particular warning in the future as we've already reconciled ourselves to this. We don't think it's a false positive, but for our purposes, we don't care. I think that's a really exciting use of large language models that reap the benefits of it without some of the concerns that we all feel, I think, around relying on poorly written large language models or poorly trained ones. All right, so a couple more questions from Raj. Is it feasible to integrate SAST with a real-time abstract interpreter that proves the absence of security violations during runtime execution? I'm going to say, so I don't think we should treat static analysis as a prover, right? I'm not sure if that's what you're asking, but I think there are some certain limitations that static analysis has. Um, there may be theoretical ways to achieve what you're talking about, Raj. I'm not convinced that it would be easy to do or necessarily very accurate. Um, I never want to say no, but I'm not really aware of anyone that does that. So, taking the idea to its maximum, I think you would have to feed your static analysis engine something that was really constrained. So I think Spark would be a better, something like Spark is probably a better choice if you need a more formal language that has its own self checks baked in. I think with C and C++, and certainly with Java and C# and other memory safe languages, I think there's just too much in there that we won't have insight into, like runtime libraries, variation between different compiler models and compiler vendors and chips and built-ins. I just don't see it happening. The other thing I wanted to mention is, if I don't get to your question, because we are really very, very close to time, I will do my best to get this emailed out to you. So I will try one more question, and I think at that point, I'll probably have to call time and thank everyone as well. So final question: how can shift left SAST analysis be mathematically proven to reduce? Yeah, okay. So MTTR for all code bases, regardless of project language, entropy. So again, it's not a prover. Static code analysis is good for detecting known patterns or things that are, the algorithm has to be looking for. And I think if you want a provable or a software prover, you need to pick a language that's a little bit more precise. So Spark comes to mind because that's why we built it. But I think when we're talking about developer entropy, cross compilation, different system clocks on different machines, just the sheer challenge of trying to deal with all of that variability. I don't think general purpose static analysis in C and C++ will ever be amenable to that kind of an outcome. You have to pick a language that's provable, and you have to live with the limitations of static analysis, even for shift left. So for pure accuracy, it's going to be a combo platter of different techniques and technologies, but just relying on static code analysis is probably a fool's errand in that case. All right, so thanks to Raj and to everyone else who asked such great questions. I don't think I'll have a chance to get to any more. We've got 2 minutes left. So I just wanted to thank everybody for your time. I know how valuable that is, and spending an hour with us on a Tuesday afternoon or evening is very much appreciated. So as I mentioned, we will send out links to the slides and to this presentation. If you're in a hurry, you can grab the slide deck from the links in the bottom right of the page. And let's see if I can get to the results of our poll, because I think that might be the last interesting thing to explore. All right, so I apologize, but the poll results. So, interesting. So 42% have responded that DevSecOps is a long-term goal. 36% of attendees today are in the process of adopting DevSecOps. So hopefully this was useful for you. And 22% are already using it. And so I hope for that crowd, this is something that you think about adopting or enhancing with static code analysis. Again, thank you very much for your time. I think we're right on time, and I bid you adieu.